Hey, so Leetcode number three, which is also Leetcode 100, which is same tree. So you're given the roots of two binary trees, P and Q, and then you need to write a function to check if they are the same or not. Two binary trees are considered the same if they're structurally identical and the nodes have the same value. So same and have same value. So you're given the roots, right? So before you can even start, for something to be similar, that means both of them can't return null. So if not P or not Q, return false. Right off the bat, these two lines of code mean if not P means if P is not a valid, if it's not valid means it's returning null or it doesn't exist. Or if same thing with Q, it's returning none, invalid, or it doesn't exist, it'll return false. But this is for or. Or. Or means one exists, one doesn't. So for this one, two, you have one, two, but for this one, you have just one. You don't have two. That's the or. Like this is something, but this is something. Or say just for the nodes, you have one, which is a valid parent node or valid root, and then you have this, which is none. So this doesn't exist. So you're comparing a root tree that exists with a tree that does not exist. So you get a value of one versus a value of none. So it's or. But then you can also have the primary case, which is if not P and not Q, which means that both don't exist. So they're both the same tree because they're both none. And in this situation, we'll be returning true. Now, this is if they're structurally identical, considering the roots, since which is what we're given, the roots P and Q of two different binary trees. So if the roots are similar or not similar, we have these two cases done already. Now what we need to look into is the second case, which is values. So let me put this over here, and we'll have this as a structure being the same for these. Structure is same. Now for these, for the next condition, we need to consider if the nodes have the same value, right? So for that, it would be if P dot val is not equal to, or if we do equal to Q dot val, this could also be return true. But this whole the definition, at least in Leetcode terminology, is like this is saying if it is the same tree. So technically, what we should be dealing with is inverse scenario. So if this is not the same, we want to return false because this function will automatically result it as being the same tree. So we're only really dealing with false situations. We only have to do this because we're establishing a base case, right? This is as you go on. This is an established base case in the root. This is as you go on. So it's just the given value of that is a similar. So if you're looking into it, the value of P is not equal to the value of Q, right? Even so for this to be the same tree, right? You have one and one. That means that they exist, right? This doesn't have to be one, and this does not have to be one. This could be one and two, right? Like you could have where's draw.io? Draw.io, right? Discard, yes. Discard, yes. You could have two trees. Why is it not zooming in? Weird. Okay, yeah, so you could have two trees, one as parent node, and you could have two as parent node. The values are different, but structurally they both exist as a parent node with the left, a dot left, and a dot right, dot left, and a dot right. So that's what we established over here, the structure for the root. Now we're starting to look into the values. So this is not the same tree. Now, if you're looking into the values, it is not the same tree because values was and the nodes are the same values. That was a consideration for the binary tree to be identical if they have the same value. So one and two is not the same value. this would be this condition, the exclamation equals, which means not, which is what we have here, exclamation equals. So now we're returning false. But I guess for sake of just knowing, you could also do q.value and then return true. But again, that's not necessary, but like for the sake of doing one, just for explaining and sake of understanding, we may as well just do it, right? It doesn't harm. It'll just return true regardless. For bigger algorithms, you shouldn't be doing anything that isn't necessary. But of course, if we're dealing with the Leetcode, we should get similar answers regardless. Now what we do is we need to do something as we iterate. So we'll be using DFS as depth first search. And so as we iterate, you're gonna be using the dot. The dot is capital S same tree, and this comes X and Y. Now as you iterate, your X will always be dot left, and then your Y will be dot right. So what this is saying, dot is same tree, so it'll be dot is same tree. Now you have x dot left and y dot right. Now these x and y are basically just the two different roots, right? So you could do q dot left and p dot right, but we wanna first traverse for the left of both. So what we're gonna do is p dot left. So we're gonna first go through q dot left and p dot left. But I guess let me make it like this since it's easier to understand. So this is what you have. So it'll be the same tree if once you traverse through all of the p parent node or root node, you look through all of its left values, and it's the same. This same tree will return as true, right? So basically, this whole thing is a return statement at the end of the day because there's nothing else left. So now we should return something as it's iterating through the whole thing, right? And if you have something in a return statement and you have another command afterwards, right? What that means is that if this whole command returns to be true, it'll just be returned true, right? And it's one less line of code we have to write. So for this one, since this is a class of solution, right? So if we're returning something to return self.isSameTree, so this is iterating for all values left of the parent node. We need to do and self.isSameTree. Now we need to iterate or traverse right. So p.right, right, and q.right. And now sorry, not this. So now if all the left values of the nodes are the same and the right values from the root node are all similar, this should become true, and it'll just be returned true, which is what we want because it'll be the same tree. But if it doesn't return true, it'll return false. But it means it's not the same tree. Now let's try running this code. Oh, interesting. Case 1. Return p.left, q.left, and self.isSameTree, p.right, q.right. Maybe it's an error with this. Maybe at the end of the day it really is unnecessary. Let's try running it. And yeah, so yeah, that was the error we had. It was really just unnecessary at the end of the day. And yeah, as you can see, we have a runtime of beating 100% and a memory beating 94.05%, which is very optimal. And this would result in our optimal solution. Thank you.